Oh, all right, there we go. So, hey, we are in lesson 14. We're still talking about absolute value, and it's part 2. The title here, I believe, is the same title, like what we're looking at doing. Analyze and describe the effects of adding a constant term to an expression defining an absolute value function. All right, so let me write that down because some of you are taking those notes. I lost my, there we go, let's pause. All right, so analyze and describe the effects of adding a constant term to an expression defining an absolute value function. So here to start out, Toronto is a city at the border of the United States and Canada, just north of Buffalo, New York. Here are 12 guesses of the average temperature of Toronto in degrees Celsius in February of 2017. So the actual average temperature of Toronto is 0 degrees Celsius. Oh, cold. Use this information to sketch a scatter plot representing the guesses X and the corresponding absolute guessing errors Y. So we're just subtracting those values from 0. So our absolute value, this is what we're plotting. So our guess is 5 and our error is 5. So we're going to plot 5, 5, 2, 2, negative 5, 5, because it's the absolute value, 3, 3, 0, 0, negative 1, 1, or 1.5, 1.5. These are XY variables. Negative 2.5, comma 2.5. That didn't come out right. That's a positive 2.5. 6, 6, 4, 4, negative 0.5, 0.5. So let's plot those really quick. I'm going to go ahead and push pause, though, and you can plot them too. All right, there we go. Okay, we have a nice scatter plot, and that scatter plot spits out what looks like an absolute value function. Pretty cool. What rule can you write to find the output given the input? So to find the output, absolute value of the input. Okay, the rule for this one is much simpler because the actual value is 0, so the output is just the absolute value of the input. No big cool thing there, right? All right, so last lesson we did the guess minus the actual, or the actual minus the guess, but since our actual is 0 for this one, where's my pen at? There it is. Since the actual was 0, we didn't have to do any subtraction. It was much easier. All right, we could also say that it's sort of like your input minus 0, or your 0 minus input, to keep with the same pattern as the last lesson, okay? All righty. So to work through, we are talking the distance function. So the function A gives the distance of X from 0 on the number line, which is really the absolute value function, which is the distance function. When I was little, I learned the absolute value means you just make your number positive, but that's not really true. The absolute value of a number is the distance from that number to 0 on the number line. So if we have a number line and we have 0, if I have a number, say negative 5, the distance from that negative 5 to 0 is 5. That's why the absolute value of negative 5 is 5. If we have 5, the distance from that number to 0 is 5. So the absolute value function is really the distance function. All right, so complete the table and sketch the function A. So, right, this one, it could be either negative 5.6 or 5.6. Like, I could say this one's negative 5.6. The distance is 5.6. I could also say it's positive 5.6. Pi, my distance is 1/2. This could be 1 or negative 1. I guess I should do that. It could be either. Just like I showed you here, the distance from -5 to 0 is the same as the distance from 5 to 0. 0, that's an easy one. -1/2, +1 or -1, and this could be 8 or -8. I mean, I guess we went positive to negative. So we should make this one negative since I didn't see that both of them were there. This one should be positive, just if we're going on a number line, and this one should be positive. No biggie, because we have a positive and a negative. Cool. All right, and then sketch the graph. So actually this graph, if we sketched it, I'm going to do my best. It is actually a line segment with a slope of 1 and a line segment with a slope of -1. I can do it. Oh, I got pretty close. All right, cool. So Andre and Alina are trying to write a rule for this function. Andre writes, the function equals x when x is greater than 0. The function equals -x when x is less than 0. All right, and then Alina writes a of x equals the absolute value of x. Explain why both equations correctly represent the function a. If we look at Andre's, so here we have a of x equals x when x is greater than or equal to 0. So that's this part right here. So if my input is 2, my output is 2. If my input is 6, my output is 6. So a of 2 equals 2. A of 6 equals 6, etc. And then we could say that a of x equals -x when x is less than 0. Okay, that's here. When the input is -2, the output's 2. And think about that. When the input is -2, the output is 2. Kind of magical, huh? When the input is, I don't know, -6, the output is 6. Okay, and that's this side of my graph right here. Notice 0 only goes with one of the two graphs, and then we picked this one. It actually could be either, but it cannot be both. The number 0 has to go with the x is greater than 0 or the x is less than 0. Can't be both. We need that equality to only be one of them. And then Alina writes a of x is the absolute value of x, which is the definition of distance. So that one is perfectly okay also. And then moving graphs around. So here's where we really can practice how graphs move. This is the function we've been talking about since we started, just the basic absolute value function, which the origin is where the v is. Now, if we have x minus 2, that shifts your v 2 to the right, 2 to the positive side. Okay? Here, we've got x plus 2. That shifts us 2 to the left. And I know it's x plus 2, but it's 2 to the negative side. Right there. Okay, and now we have absolute value of x minus 2 shifts us 2 down. We're outside of the absolute value sign. And then plus 2 shifts us 2 up. Right, I'm going to go to Desmos because I believe I can. There we are. So absolute value of x, right? Keep it in the parentheses, x minus 2 should shift to the positive side. There it goes. Absolute value, so x plus 2 should shift it to the negative side. Cool? Now, if I do absolute value of x plus 2, that's going to go up. Cool? Purple. Guess what we're doing next? Minus 2 is going to go down. That's not a mistake. That happens every time. It's very cool. All right. Let me look at my paper. What else were we going to do today? Notice that the number 2 appears in the equations for the functions f, h, g, and k. Describe how this addition or subtraction affects it. We just did. Then think about a possible explanation for the position of the graph. How can you show that it really belongs where it is on the coordinate plane? We're good. All right. That was a light lesson, but so important for your understanding of how all of this works. So I hope that you can soak it in. Okay. That's it for today.